Namaskar. Hello, friends. In this COVID-19 pandemic lockdown time, most of you must be in the home and trying to use good use of the time that you have in hand. Many of you must be trying to explore the various knowledge resources through which you can gain your knowledge. And today also I'm going to talk about and one of the special event, astronomical event, which is going to come on 21st of June 2020. I hope you will enjoy this presentation and will try to learn about how such events have made important, played an important role in terms of an astronomy. So let's talk about it. And as we all know, the solar eclipse is basically a phenomena which happens because of the hide and seek game of the three different objects. In this particular phenomena, we know that sun gets hidden by the moon for a certain period of time, and the region on the earth passes through that shadow of the moon, and we see the eclipse happening. So let's talk more details about these three objects. Of course, not very in much details, but certain details about these three objects as far as the presentation is concerned. So we all live on the planet Earth, and we all know the planet Earth has an average temperature about 15 degree Kelvin or the 15 degree centigrade. And we know that Earth revolves around the sun in a 365 day. And in 365-day time, there is a particular occasion or there is a particular day on which Earth goes very close to the sun, what we call it as an perihelion location. And when Earth goes very far away from the sun, we call aphelion position. And if you try to see the distance to which Earth goes near the sun or Earth goes far away from the sun, then it's very interesting to know when the Earth comes very close to the sun, then the distance between the Earth and sun is about 14 crore 70 lakh kilometer. And when Earth goes far away from the sun, the distance between the sun and the Earth is about 15 crore 20 lakh. So averagely, in a year, Earth goes 50 lakh kilometer difference from its farthest and the nearest distance from the sun. And this plays a very significant role, which we'll try to see in our next few slides. Now, when we talk about a next object, which is moon, and of course the first closest object from the cosmos for the Earth is a moon. The moon is average about 3,84,000 kilometers away from the Earth. And equally, as the Earth goes very close to the sun on one day in a year and goes very far away from the sun once in a year, similarly, moon also comes very close to the Earth once in a 27.32 days and also goes far away from Earth once in a 27.32 days, because 27.32 days is a period of revolution of the moon around the sun. Now, the same thing happens with the moon as well, because we all know in the 17th century when Johannes Kepler gave us an idea and has proved that all the planets move around the sun in an elliptical orbit, and equally moon also revolves around the Earth in an elliptical orbit. Being in the elliptical orbit, moon comes very close to the Earth of the distance of about 3,64,000 kilometers. What we again call it as an perihelion location or a perigee. in more specific. And when the moon goes far away from the earth, then it goes of the order of 4,05,000 kilometers. So on an average, you can consider the moon also come about 50,000 kilometers from its farthest location as compared to the 50 lakh kilometer in terms of the sun or the earth closest to the sun. Because of this particular difference in the distances, there is something which is very interesting thing happens, which will be see in a next few slides. Now we'll talk about the third object in our solar system, or rather the third object as far as the annular solar eclipse is concerned, and that's the main source of energy for entire solar system is nothing but the sun. Sun is very interesting object to study and learn about, because it has got huge amount of kind of a mass of the solar system. It has a main source of energy for the entire solar system. It has got the very informative things in the sun, which produces the energy because of the continuous conversion of hydrogen to helium. So as we said, the sun also revolves, rather earth revolves around the sun, and the same sun come close to the earth, or vis-a-vis earth goes close to the sun. And that gives rise to a very interesting part, which we will see in the next slide. By the way, the sun has a radius of about 7 lakh kilometer in comparison to earth, which is only 6,400 kilometer. And the mass of the sun is about 10 raised to 30 kg. And if we just consider the amount of mass the sun exists, as far as the entire solar system is considered, then it is about a 98% of the mass of the solar system is inside the sun. Only 2% of the mass of the solar system is distributed among all the planets, satellites, of course, natural satellites, comets, asteroids, everything that we talk about as in solar system. So that is what is the importance of sun in terms of the other objects of the solar system. Now, if you remember, I was just trying to mention you that sun come to very close to earth, or vis-a-vis earth goes very close to the sun, and the moon also come very close to the earth, and moon also goes very far away from the earth. When the moon is at the closest approach, we call it as a moon is at the perigee location, which is at the distance of about 3,64,000 kilometers. Now, what you observe on this particular slide is nothing but the size of the moon. If you look at the size of the moon, you will realize the size of the moon is changing. That means the size that we see here is nothing but the angular size. This is nothing but the angular size of the moon. But in case of the moon, you see the angular size of the moon is very comparatively appears to be large difference as compared to the sun, where sun doesn't go much in the angular difference as far as we see from the earth. And it's quite possible, or logically also one can imagine, because in comparison to sun, moon is very close to us, and we see size variation of the moon is a little more than the size variation of the sun. The bottom picture tells you about the variation of the size of the moon and the variation in the size of the sun. And this variation in size is nothing but the angular size of the sun and the moon. And these two variation in the size of the moon and the sun gives rise to understand various aspects of the sun, or various aspects of the solar annular eclipse. Now let's talk about very interesting part in the solar, rather the such kind of an angular sizes. Now here there are three aspects which has been trying to show as far as the angular size is concerned. When the angular size of two objects which are almost equal, or a small bit of a difference is there, then what we see is the eclipse. And the first image animation that you are able to see is the because of the angular size of the sun and the moon is almost same, that's why we see the eclipse happening. But when the angular size of the uh, inferior means closest to the earth, is very small as compared to the object which is farthest or the from the away from the earth, then the size of the object which is far away will appear bigger in size, and the size which is closer to the earth, which is very small in angular size, then the phenomena that can happen is in the background of the secondary object, the primary object can actually move in front of the primary object. And we see such phenomena as a transit. And as far as the earth is concerned, we can see the transit of two inner objects. Of course, inner object means from the aspect of an orbital location. So from Earth, we have two planets which are inside the object of the planet Earth, that is planet Venus and planet Mercury. So we can always see the transit of these two planets when they move in front of the disk of the sun. Now, exactly opposite case happens when the primary object is bigger in angular size as compared to the secondary object, which is the farthest from the Earth. Then such a phenomena, when hide and seek happens, the kind of phenomena that you see is called the occultation. And we all know moon is the closest object to the Earth, and the stars which are point source object that we see always in the sky, those stars can go behind the moon. Of course, every star doesn't go behind the moon, but the objects which are falling into the let us say the orbit of the moon or nearby the ecliptic, what we could actually see, some of the stars go behind the moon, and that hiding can keep the object behind the moon for a very quite a long period or for quite long time, and those phenomena we call it as a occultation. So because of the angular size difference, we can see such kind of a phenomena. Now, as far as this talk is concerned, we'll talk about the various type of eclipses. And because of these three objects, as we know, what are the different type of eclipses can be possible is one kind is called the solar eclipse, and another is of course the lunar eclipse. Now, what is the anatomy of this eclipse? By and large, most of you must be knowing, when the moon comes in between the sun and the earth and falling onto the straight line, which enforce the shadow of the moon falling onto the earth, and the portion which goes from the shadow of the moon, only those people can get, sun can get hidden from the visibility, and those people can see the solar eclipse. Exactly opposite, you can imagine, when the earth comes in between the sun and the moon, and the shadow of the moon shadow of the earth falling onto the moon, then such phenomena we can always see as a lunar eclipse. Now, why does the solar eclipse occur? Well, by and large, if you try to see, there are two major aspects that we'll have to remember. One is because of the position and the places the sun, moon, and earth are. That is one of the factor which is responsible to have such kind of an eclipses. Now, that means what? Having a sun at the distance of 15 crore kilometer, having a size of about 7 lakh kilometer in radius, Earth from the Earth, what we see, the angular size is about a 30 arc minute. Similarly, Moon being a 4 lakh kilometer or 3 lakh 84,000 kilometer away from the Earth, and of course having a radius about 1700 kilometer, gives rise to the almost equal angular size as far as the Moon and Sun is concerned. So having an angular size of the Moon and the Sun is the another aspect which is responsible for making such kind of an eclipses to happen onto the Earth. Now, why do it happens? What is the basic reason? What is the science behind it? Why it happens is, as I said, if you remember, there are two aspects which has to be remembered very correctly. There is a number comes out, or a ratio of two things. One, if you see the sun's location and the moon's location, then you will realize the distance between the sun and the distance between the earth and the moon and the distance between earth and the sun, then it has got the proportionate of 400%, 400 times. Another aspect is sun at that distance and the size of the sun, which is about 7 lakh kilometer in radius, and the moon at the about 3 lakh 84,000 kilometer of 1700 kilometer in radius. If you do the ratio of the radius of the sun divided by the radius of the moon, that ratio also comes around 400, giving rise to understand that sun is a 400 times larger than the moon, but at the same time it is a 400 times farther from the moon. Those ratios are making responsible that both the objects appears to be about a half a degree in size or a 30 arc minute in size, and as a mere coincidence they produces, or rather the moon produce the shadow of the moon, rather the shadow falling onto the earth, and equally when the shadow falls onto the moon we see the lunar eclipse. Now when do the solar eclipse occurs? Of course it is true that solar eclipse can happen only on a new moon day, that is on the day of Amavasya. But does the every Amavasya has the solar eclipse? No. This particular picture can illustrate you that on every Amavasya this is not going to be possible. Why? Because the orbit, the moon's orbit that we have, which with the ecliptic is 5-degree inclination. Because of the difference in 5-degree inclination with the ecliptic, what happens is the most of the time the shadow of the moon or the shadow of the earth remains in the space either below the moon or above the moon, or equally below the earth or above the earth as far as moon is concerned. So that doesn't allow it happen the solar eclipse on every new moon day, or a lunar eclipse on every full moon day or full moon night. Now let's look at the type of solar eclipses. We have got because of the shadow play, we have got 4 major types of solar eclipses that happens. One is called the total solar eclipse, and we see this picture also. In this, it is very easily observable. When the shadow of the moon falling onto the earth, the shadow has a 2 different aspect or 2 different types. One is called the dark shadow, we call it as an umbra, and there is a fender shadow which we call it as an penumbra. Now the region on the earth where the umbra falls, from that location what we see is the solar eclipse, which is a total solar eclipse. Now what is important in this particular image that you could think of? If you try to see the shadow falling onto the earth, it is of course a solid angle falling onto the surface of the earth, which encompass about 270 square kilometer size, which is the area of that sphere or area of that circle that we could imagine. So at any given time, only people falling in this 270 square kilometer area can see the total solar eclipse. Rest of the people, or of course not rest, but beyond that, large amount of people can see the what we call it as a partial solar eclipse, wherein the penumbra shadow falls. But in this picture, it is quite clear that there are a large amount of area on the earth where there is no solar eclipse happens at all, even though there are certain people who can see the solar eclipse. Now, here there is one of the important aspect that I would like to emphasize. We all know moon is revolving around the earth, and moon is revolving around the earth, and the sun, earth is revolving around the sun. That means all these objects have their own speed, and because of that, shadow also doesn't stop at one place for a longer time. And the rate with which the shadow moves is tremendously very high, which is of the order of 1700 kilometers per hour. So it allows only for a certain amount of time that you could see the total solar eclipse or even a partial solar eclipse. And if you do the small calculation, you will realize that at one particular place, if the solar eclipse falls or the solar eclipse passes through, then the the probability of having the another solar eclipse or the total solar eclipse at the same place is enormously very high, which is of the order of about 360 years after it can fall on the same place. That's on an average, it's not exactly. And then during the total solar eclipse, what you see is the variety of the layers of the sun's atmosphere. In this particular picture, you could see the phases in which the total solar eclipse happens. It partially cover the sun, and at the exactly at the time of totality, moon can cover the entire sun, and we can see the outermost layer of the sun's atmosphere called as an corona. And of course, the before the corona is about to begin, what you see is the chromosphere, which is the second most layer of the sun's atmosphere, and the thickness of this chromosphere is just about 2,000 kilometer in size. This layer that we can see only during the total solar eclipse. Now, the second type of solar eclipse is the one which is upcoming. It's called the annular solar eclipse. In this particular image, that what you could see is the actual, the shadow of the moon get vanished well before it falls onto the earth, and from there the another shadow emerged. We call it as an inverse shadow, or we call it as an antumbra. So the people falling into this antumbral shadow or in the reverse shadow, we only those people can see the eclipse in which the sun appears to be like an annulus. It's like an bangle that you could imagine. And again, for large amount of people, they see the partial solar eclipse. So it is very essential to understand that in annular solar eclipse, what falls onto the surface of the earth is the antumbral shadow. Now, the third type of solar eclipse which can happen is called the hybrid solar eclipse. Hybrid solar eclipse is a very rare event, but it does happen. And what is the hybrid eclipse? Is that when, if you try to see the belt in which the eclipse is passing, for certain people it appears to be like an annular solar eclipse, and for certain people it appears to be a total solar eclipse. So a single eclipse having both the phases, we call it as a hybrid solar eclipse, and it is very, very rare phenomena. But in an upcoming year, that means in 2023, not immediately, but next, after 2 more years, we are going to see the hybrid solar eclipse. Of course, not from India, but from the different part of the earth we can see. Now, the third kind of an solar eclipse is the fourth type of solar eclipse is nothing but the partial eclipse. And as I have already explained, partial eclipse is the location through which the penumbral shadow falls and people can see the sun passing through the phases, but moon doesn't appears to cover the entire sun. So this is how the phases of the partial solar eclipse moves when the sun is there. Now, how to see the sun? Then of course we should never look at the sun with the naked eye, but we should make use of an authenticated, well-approved solar filters released by people who are working in the field of astronomy for a very long time, or any government institution who work for the astronomy. Of course, Vigyan Prasar also worked for them. So we do release such kind of a solar goggles because that solar goggles can reduce the intensity of the sun almost a million times the light that we see with the naked eye. And then only looking at the sun is safer. If we don't have solar filters, don't look at the sun, but then you can use the pinhole camera to see the sun, or to, of course, to see in its projected image of the sun. Then you can make use of the ball projector. We can use the telescope to get the projection of the sun. And with this also, you can see the solar eclipses. Now, we'll just emphasize on us 2 more minutes. Why do such kind of solar eclipses are so important? I would say that, well, in 2020, certainly these eclipses are not really going to be much important as far as the science is concerned. But, well, only such kind of eclipses have helped us in confirming some of the facts that we are known today, like moon is spherical in shape or earth is in a spherical in shape. These phenomena, these solar eclipses have helped us in confirming those facts that we know over a long period. Now, certain amount of research also was been conducted, which also gave us the idea that sun has altogether a different gas which we never seen before on the Earth, and that is nothing but the gas called as an helium, discovered on the sun. Helios is the name of the sun in the Greek, and we use the helium as a name for the gas which is available on the sun. So in 1868, India is been recorded its name because on 18th August 1868, the total solar eclipse was passed through the Andhra Pradesh, specifically from the Guntur in India, and we observed, rather not we, means the team of the scientists have observed the solar corona, or the layer of the sun's atmosphere, and they have found that there is a presence of the helium into the sun's atmosphere, which was the first time discovered in 1868. So at that time also, total solar eclipse played a significant role in discovery of the helium gas into the atmosphere of the sun. Similarly, if you remember the millennium scientist, we call it as an Albert Einstein, who gave the idea about the general theory of relativity. According to the theory of relativity, it was been said that if the object is highly massive, then the object can even bend the light when it passes through that object. And when the theory was put forth on the by the Einstein on the paper, it was highly needed that we should have some proof about it. And in 1919, the first eclipse which occurred after the research paper which was published by Einstein, the Arthur Eddington from the Cambridge, from the Britain, and his team decided to make use of such eclipses to find whether there is any bending of light happens. And on the 29th of May 1919, when the eclipse passed through the Principe Island in the African, they have really observed the stars which are almost some 3 arc minute inside the disk of the sun are appeared little away from the sun, and it was a very good proof of general theory of relativity. Well, such kind of an eclipses are still important as far as you all children are concerned. You should do such kind of an activities. You can very easily measure the relative velocities of the sun and the moon. You can find out the diameter of the sun, diameter of the moon. Of course, these are relative diameters. You can also find out the percentage of the eclipse. You can find out the maximum time of a eclipse. All those activities that you can do with the help of simple graph projection of the sun and putting it onto the graph papers and all. Now, after this particular eclipse of 21st June 2020, the next solar eclipse is going to happen only on 20th, of course, visible from India. Visible from India will be on 21st of May 2031, which will again pass through the northern part of the India. And sorry, that will pass through the southern part of the India. And the next total solar eclipse, which will pass through India, is on 20th of March 2034. So to see the total solar eclipse, we'll have to wait for another 14 years, which will pass in from the northern part of the India, which is very close to the Pangong Lake, just to have an information for all of you. Now let's come to the second part of the presentation, and it's about the annular solar eclipse of 21st. On the 21st of this June, annular solar eclipse, we also call it as a ring of fire because you see the sun as a ring, and this annularity will start early in the morning when the eclipse sun, rising sun, will be eclipsed for certain people from the Central African Republic. Then it will move from the Congo to Ethiopia to Yemen, and then it enters into the south of Pakistan, then to India. It moves to China, then Taiwan, and then ends up into the Pacific Ocean. And this is the belt that you could see on the picture. That this starts from the middle of the Africa. It moves from Yemen, Oman, then it from Pakistan to India to China, Taiwan, and it ends up by evening time into the Pacific, South Pacific Ocean. Now, as far as India is concerned, if you look at the India, it passes through the 4 major states of the country. Well, the fourth state, which is Uttar Pradesh, only it's like a grazing, it's just touching the Uttar Pradesh. So we actually cannot say passing through the Uttar Pradesh, but still some of the places from Uttar Pradesh are going to be, seen for the annularity. So for as far as India is concerned, it will starts from the Rajasthan, it will go to the Haryana, then to Uttar Pradesh, and then to the Uttarakhand, and that is how it will move towards the China. Now, as far as the major cities of India is concerned, we have just depicted the five major cities of the country like New Delhi, Kolkata, Mumbai, Bangalore, and Chennai. And it's quite easy to imagine or quite easy to understand as we go towards the south, the percentage of eclipse will certainly drop down. But as we move towards the north, because the annularity is in the north, we could see the annularity or the percentage of eclipse is quite high. So that's why in Delhi, you will see nearly 93.77% of the sun is covered. Then if you see the Kolkata, which is well comparatively in the north as compared to the Bangalore and Chennai, and Kolkata will have nearly 65.52% of the eclipse. Mumbai being in the western part and in towards the south, so Mumbai can see 62% of the eclipse. Bangalore will see less than that, that is 36%. Chennai will see only 34% of the eclipse, which is of course a partial solar eclipse. So majority of this cities that is highlighted here, all major cities are going to see only a partial solar eclipse. Now, as far as the region in which the annularity is passing, that means the rings of fire can be seen. Of course, there are a lot of regions, but we have mentioned here only five places. We call them as an hotspot. On the 21st of June, the eclipse, these five places you could see, the annularity will be visible, and those places are in Rajasthan. You see it is passing from Suratgarh, then you come to the Haryana, then we have Kurukshetra, Yamunanagar, Sirsa, and as you go towards the Uttarakhand, we'll have a Dehradun. So this is how the eclipse is going to pass through. And if you try to see the maximum annularity time, I'm not going to read everything in details, but what you could see here is the minimum annularity that can be seen is about the 9 seconds, and that 9-second annularity will be from Dehradun, but the annularity will little increase for Kurukshetra and then to the Suratgarh, which is about 27 to 30 seconds. And then of course Sirsa will also have about 24 and Yamunanagar about 23 seconds. So for very, very small, for fraction of seconds only, you are going to see the annular solar eclipse, and that's a wonderful time that we should make use of it to observe the sun. Of course, with the proper filters that are available, released by the proper people. Now, as I said, what are all the different things that we could see? As I earlier said, that you can find out the maximum annularity time, you can find the duration of eclipse, you can find the percentage of annular solar eclipse, you can measure the angular size of the sun and the moon. So all those activities that you could very easily see. And in this pandemic period or in the lockdown period, certainly most of you may not be able to see the eclipse because all of you will not be falling from this annularity belt. So I will strongly request, because this is the eclipse which is starting almost at about 10 o'clock. If you want to see that, as far as the annularity is concerned, it is going to start about, the eclipse is going to start about 10 hours and 15 to 20 minutes, and it will end up at about 1 hour 50 minutes. So you have got almost 3 hours and 30 minutes time to see the eclipse, and the time of maximum eclipse is almost at the mid of the noon, that is about 12 o'clock or about 11:30 to 12 hours and 10 minutes or so. So at that particular point of time, the sun will be quite up in the sky, and in every one of us can very easily see the sun, provided you have the filter with you, and then you can observe the sun with the solar filters, just going on to the top of the roof and enjoy those events. Or otherwise, the best way is to project it and see the projection of the sun. And I hope you will enjoy this phenomena, because after this particular 21st of June, we'll have to wait for another 10 more years to see this particular annular solar eclipse. And this is very fascinating that we should make use of this particular events to enjoy the nature. And as I said, in the belt of annularity, what is something which is very very astonishing to remember or to observe is, um, we all being an intelligent and creatures on the earth, we know the eclipse is happening, so we are prepared. But the animals or the trees, those are absolutely unaware about this particular phenomena, so they behave differently. So from the annularity belt, you will see the birds start going back toward their nest, thinking that the sun has about to set, and it's like an dark is going to come, the night is going to come. So even the trees behavior, nature's behavior is also something that we should try to observe. So the people falling onto the annularity belt, or students who appears to be into the annularity, they should see those phenomena by the nature. I hope this is something that I just wanted to share with you. I hope this event is going to be remembered by observing the solar eclipse and enjoy this event. I hope you have enjoyed this presentation. With this, thank you so much for listening to my talk about the annual solar eclipse. Thank you so much.